So we're talking about functions today. JavaScript functions are, as I mentioned, one of the kind of like main building blocks of writing code. So we've already used a lot of functions in P5 throughout the semester. And we've seen the word function, like when we start a new P5 sketch, we always see function setup and function draw right from the beginning. So we've seen the word function a bunch of times, and we've kind of know what it does, but we're going to talk in more specifics today. And we're going to write some of our own functions. So even though we've been using functions throughout the semester, we haven't really created new functions, which is one of the things that we'll talk about today. So functions are just blocks of code that we can call or execute or invoke. There's a bunch of different words that people use for calling a function. And they're sort of like variables in the sense that with a variable, you have a short hand or name to keep track of some data. In functions, we also have a shorthand, a name for a function, but instead of keeping track of data, it keeps track of a little bit of code or a series of statements in code. So there's a lot of similarities between variables and functions, and in JavaScript we can even declare functions as variables. But the main difference again is just that a function is not data; it's a series of steps, or it's a series of code that we put together. So when we write a function, we always start with the word function. There's actually other ways to do it, but this is how we normally do it. So we start with the word function. Let me make sure I have, and then we just give the function a name, just like a variable. So if I was going to make a variable called, oops, banana, I would say something like that. For a function, it looks a little bit different. It looks more like one of our control statements, like if parentheses, then we have a code block, or for parentheses and a code block. Our function looks a little bit like a combination of those two things. So we start with the keyword function, we give our function a name, and we should follow the basic camel case parameters. So if I had like my function, the second word in my function name would be capitalized, just like we do with variables. That just makes it easier to read. But you can really call a function whatever you want. There are some words that you can't use for a function, just like variables, but most of the time you can use whatever you want. So I'm just going to use a function called banana. And then after the name of the function, we put a parentheses. That's how we know it's not a variable as well. Function's always followed by a parentheses. So you probably remember writing something like ellipse uh, with parentheses at the end, or create canvas with parentheses at the end. And we always put numbers in there, like we say create canvas like 400 by 400 or something like that. So we'll talk about those numbers in a second, but just to reiterate that a function name always has to be followed by parentheses. That's how we know that it's a function. And then after the parentheses, we put two curly brackets to set up our scope or block for our code. And so usually we hit enter to indent here. And everything that goes inside of this function, just like we've seen in setup and draw, is going to be indented over by 1 until we leave the function down here. And so this creates a new scope in our code. It's sort of like a little mini program, but we can run it more than once. So for my banana function, I'm just going to console.log the text banana. And one thing you'll notice if I write this function and then I hit the play button, nothing happened down here in the console. And I can show you that the console is not broken. I can just say console.log. Where's the, oh, whoops, I can't use a quotation mark inside of a single quotation mark. Where's the banana? So my console is working, but we don't see the result of this function. And so this is where functions are a little different than what we're used to in P5. When we have in P5 our function set up, this one is actually going to get called by P5. So whoops, did it again. I'm going to get called. So the P5 library actually looks for a function called setup, and then it runs it. Whatever's in there, P5 is going to run. So we can say what we want inside of setup. but we can't really change the name of setup because that's something that P5 makes for us. Not every JavaScript program has a setup function, but P5 always looks for a setup function and runs it. So that's one of the nice things about P5 is that we can create this function and then we don't have to decide when we're going to call it. But most functions that we create on our own, they don't get called by a library. We have to call them ourselves. And so we can do that by retyping the name of the function and then just putting the parentheses at the end and a semicolon at the end. So this is called, the first bit is called declaring a function. And this is called invoking a function or executing or calling or running. We use a lot of different terms to say that we want to make the function go. So now we see banana gets run. So this line gets run down here. And our setup function is still getting called, so that happens again. And we could call banana again in here as well. And we could also call banana again once we leave this function. We can call the function as many times as we want. So in JavaScript and most programming languages in general, once you declare a function, you can call it as many times as you want. So it's sort of like our ellipses. P5 defines the ellipse function for us, but we can make as many ellipses as we want. So it's kind of like a little, it's just like a little recipe that we can do multiple times. Okay, so we've declared a function, we've run a function. Let's talk about what these numbers, like if we have create canvas and then we have 400 by 400 and we run that and we get a little canvas, although we can't see it because I didn't draw anything on here. So those numbers, let's get rid of this setup function because we don't need this anymore. Those numbers are called arguments. Um, so an argument is like a little parameter that we give to a function to tell it exactly how to work. So when we're creating a canvas, we have to tell the canvas how wide we want it to be. That's the first number or argument. And we give it a second number for how tall we want it to be. So that's the second argument. Sometimes we call an argument parameter. So let's go over those. So arguments slash parameters. And we can give those parameters a name. So in my next example, I'm going to create a function called greet. And the purpose of this function is to greet a person with different greetings. So we need a couple things for this greeting to work. We need the name of the person that we want to greet, and then we want the specific greeting that we are going to use. So that way we can greet somebody by saying hi or hello, and we can greet multiple different types of people or people with different names. So to make this function work, again, I'm just going to use the console here. I'm going to say console.log, and I'm going to say greeting, and then plus, I'm going to put a little comma here, and then add the name. So I'm just adding the greeting string plus the name string together and logging that to the console. So it's not a very useful function, but it's in this case, we're just showing how this works. So when I call this function, I'm going to say greet, and you'll notice that JavaScript will let me greet somebody without actually using the parameters, and that's something that we have to be careful about. So if I run this code again, see what happens is we get this undefined here. So when I say name or greeting, this is basically a shorthand for saying something like this. Variable name equals, whatever the name is. Let's say it's Jerry. So if I don't actually put a value here, it's still declaring the name, but it's just not assigning it. And so if I have something like that, like if I go down here and I say variable name, and then I log that name, because name exists, I'm not going to get an error, but it's not going to show what I think it should show. It's just, in this case, it's an empty string. In this case, it's undefined. I wonder if this name is actually that name. No, I don't think so. Anyway, let's try n just to see if there's a difference. Okay, this is actually what I was expecting. It's undefined. So this name is actually getting hoisted into the global scope, but that's okay. Not worried about that right now. So this is So anyway, so that's like declaring a variable but not assigning it. If I call a function that has parameters, uh, then if I don't define those parameters, something may happen. Notice I didn't get an error. If I tried to console.log n, but I hadn't even declared it, then I would actually get an error, which is actually good in this case. Normally we don't want to get errors, but in this case, it's better to get an error saying that this doesn't exist if it's not working, than to get no error but get the result undefined, because undefined is not the result that we want. So this is something to be careful with in JavaScript, that you can have a function with arguments or parameters, but if you don't use them, it may still run the function. It's not going to give you an error, but it probably won't work the way you think it should. So let's put some arguments in here. So first I'm going to greet Jerry, and I'm going to say hi. And then I'm going to greet somebody else. I'm going to greet Jenny, and I'm going to say hello. So now my function works the same way both times. It just says hi. So the greeting, the second part, goes here. And then the name comes next. So the name goes after the comma. So I can greet multiple people with different names, and I can use multiple different greetings. So that's why we have parameters in our functions. So like when we're drawing an ellipse, we have some ellipses that are small, some are big, some may be on the left side of the canvas or the right side of the canvas. And so we have parameters so we can draw ellipses with the similar quality, but in different places and different shapes and things like that. So our arguments or our parameters, they're sort of like the ingredients of our recipe. You may have a recipe to make like a peanut butter and jelly sandwich, and so you may need some bread and some jelly and some peanut butter, but you could actually maybe change what type of jelly. You might have grape jelly or you might have strawberry jelly. The instructions are still the same, you take out the bread and you put the jelly on and you put the peanut butter on and then put it back together, whatever your approach for making a sandwich might be. But the ingredients can change, and that changes the outcome. You might have a grape peanut butter and jelly, or you might have a strawberry peanut butter and jelly. So that's what makes functions really useful, is if we want to do something with different possibilities, or we want to do something more than once, we can use functions to do that. Um, Okay, so let's talk a little bit about scope, which I think we've talked about before, but is relevant for our functions. And I'll use another example. And we've seen an example of this in some of the demos we've done with using interaction. We need to use global functions. So let's look a little bit more clearly at why that is. So let's move down here and talk about scope. So if I declare a variable inside of a function, it only exists inside of that function. So in this example, I have some code that's not going to work. So let's say I have a function called assign, where I assign some variables. So I'm going to say variable x equals 1 and variable y equals 2. Doesn't really matter what these numbers are. And then we have another function called add, and we want to add these together. So let's say console.log x plus y. Okay, so now if I run these two functions, if I say assign and then I say add, it is going to try to run this code, but it's probably not going to work. So let's see what happens. I put it colon there instead of a semicolon. So I get this error, x is not defined. Okay, so I defined x up here, but it's inside of this assign function. So that means that x only exists inside here. So when I get down to this add function, it doesn't know what x is because x never made it out of assign. So the way that I can deal with that is I can put a variable into the global scope. So I just take the x out of here. So I'll put variable x equals 1. And then I can assign x down here. So let's say I just declare x here and I assign x down here. So now it still doesn't work, but we're getting a different error at least. Y is not defined. Same issue here. My variable x now exists in the global scope, and so assign knows about it and add also knows about it. but the variable y is still an issue. So let's put y up here as well. And I can declare multiple variables just by putting a comma in between. So let's just declare x and y. And now we can just say variable, we can say x equals 1, y equals 2. And so now our code will work. So we console.log and we get 1 plus 2, and that gives us 3. So this isn't a normal way to structure some code, but this is something that you'll run into, especially P5, since we have setup and draw. We often use setup to declare some basic parameters about our program, and then we use draw to draw our graphics. And so we need to use global variables so that those variables exist inside setup and draw, and as well as like preload and key pressed and all these other functions that we use in P5. So that's just a note on scope, just something to be aware of. Okay, so let's get into doing some P5. So we are going to make a little button, and then we're going to use functions to abstract our button. And we're actually going to learn a new function called dist that I don't think we've actually used this before, so I don't know why. This must be in a different order than it used to be. But anyway, let's create this, and then we're going to abstract it into a function. So I'm going to create a new P5 project, and I'll call this button function. And so let's start with a little comment, button function example. And I'll put the date for today. Okay, so I'm just going to set up this example first, and then what we'll do, something that we often do in programming is if we're designing something and then we get something that we like and we say, oh, I want to use this more than once. So that's called that. What we do then is we put that block of code into a function so that we can use it multiple times. And that's usually called abstracting our code because we're taking something that does one thing and then we're putting it into like a little module, a little function to use it more than once. So we're taking an idea and we're abstracting it. We're making it possible to use it a bunch of times. So the first thing I'm going to do is create a little button. And what this does is it just detects if my mouse is inside of a circle. So it's pretty simple, but we're going to use a special function that we haven't used before, which is the dist function. So let's go ahead and look that up in the P5 reference. And what this does is it tells you the distance between 2 points. So you can see in this example here, I have a fixed point down here, and then I have a moving point that matches my mouse. And then the program is telling us how far the line is in between in pixels. So when they're very close, it's like 30 pixels, 31, 32. And if it's very far away, it's more like 100 pixels. And so it's using, basic math to do this. I think it's called the Pythagorean theorem or the quadratic formula. Which one is this? Let's see. Pythagorean theorem. I think that's the a squared plus b squared equals c squared. Yeah, so that's really all it's doing is it's taking the distance of x and the distance of y, and it's plugging them into this formula, and it'll give you the length of that line. So, it's pretty basic math, but it would be annoying to have to do that on our own. So we have a nice little built-in function to do it for us. And so that's what we're going to do. We're going to make a circle and then use that function to get the distance in between. So let's draw our circle first. I'm going to draw a circle and I'm going to put it in the middle of the canvas and I'll give the width 100. And so what I want to know is, here's the center of the circle. And circle, it's pretty easy to do this because we know that this radius is half of the size. So we know the radius is 50. And we also know that the radius is constant since it's a circle. So the radius over here is the same and the radius over here is the same. And so if all we want to know is if our mouse is inside the circle, all we have to know is if the distance between the mouse, let's say it's here, and here is less than the distance between this and the radius. So it's pretty basic to figure this out, and we'll learn some more tricks like this in a couple weeks as well for doing rectangles. So we do need to know a couple things like our x and y and size. So let's capture those as variables. So the x for this is 200, the y for this circle is also 200, and the size for this circle is 100. And we need to know those things because we need to check them against our mouse x, mouse y, and the distance. So I'll replace these guys with x, y, and size. And so now I'm going to calculate the distance. So I'm going to say variable d for distance is dist between x and y, the position of my circle, and mouse x and mouse y, the position of my mouse. And so let's look at the distance for a second. So I'm going to say text distance, and I'll just put it at the same x, y. Uh, oh, I'm drawing it uh, below the circle. Okay, so now you can see as the distance gets closer to the edge of the circle, it gets closer to 50. And as it goes closer to the center of the circle, it gets closer to 0. So that seems to be working. Let's see if I can get it to 0. Where's 0? There it is. Okay, so that's the very center of the circle. And as I move away from the circle, that distance gets larger. So all we have to test is if our distance is less than half the size. So we can say if d is less than size divided by 2, and then let's do something to change. So let's say the fill is, let's say pink. And then if it's not, let's say the fill is blue. So now the circle should highlight pink when I'm inside. Okay, so if this distance is less than 50, we see the pink circle. And if I move outside of the circle, it flips to blue. And so we can use that as a button. By changing the color, we're indicating to the user that they are, hovering over the button. And we could add other code. We're not going to do this today, but eventually we can add some other code that makes something happen if we click inside the button. So we have this nice little bit of code to create this button, but right now I can only have one button. I can change the position. So like if I change X, the button moves over here. So that's pretty cool. If I change Y, the button will move up there. And if I change the size, the button will get bigger. But it still works the same because this S is what we're using to determine the distance as well as draw the size of the circle. And so we can change the position of the circle, but if I want to make another button, I'd have to copy all of this code and paste it again and change the variable names so they don't conflict with each other. And that's generally kind of not that much fun. So what we can do instead is abstract our code using a function. So I'm going to make my own function, and I'm going to call this function button. And I already know that I'm going to need some parameters, right? I need the x, y, and size. But for now, let's just dump this whole thing. So I'm just going to copy this whole thing and dump it into my button function. And now if we take it out of draw, so if I run this, it's not going to do anything. Even though the code is still here, it's not actually being called. So remember, setup gets called by P5, draw gets called by P5. But if I make my own button function, P5 doesn't care. It doesn't know that exists. I have to call it myself. So inside my draw function, I have to call the button function. Now it'll work again. Okay, but it's still always the same. So now let's think about how can we abstract this? We can use parameters. So it's pretty obvious, it's pretty easy to see what my parameters are, right? It's these variables that I'm declaring at the beginning to make my button work. So let's put those into the arguments for the button. We have x, y, and size. And then we can just put those values into the button where we call it. So we'll put 300, 100, and 200. And so now I don't need these variable declarations anymore. I can comment these out and we'll see our button works exactly the same way. So now we have a button where 300 goes into X, 100 goes into Y, and 200 goes into size. And so now you can start to see how ellipse works, right? Like this is almost exactly the same. If we look at our circle or ellipse or circle or any of our P5 shape functions, if we look at our circle down here, it's using the exact same parameters as our button. Our button just adds a little bit of code to change the color of the circle. So now let's get rid of these extra variables and we can make more buttons with different parameters. So let's make a button at 100x and 200y and 100 size. And let's make a button at 200x and 300y and 20 size. And let's make another button at 300x and 400y and 50 size. So really any of these numbers will work and we'll get the same basic setup where if I hover over my circle, it changes the color. So that's pretty cool. I can start to design an interface with different buttons, or I can just make some interactive art where the users can change the colors or do different things. And I can make as many buttons as I want. And I can also change the basic parameter of a button, right? If I decide that the colors I'm using are not the right colors, then if I change something in here, let's say I want to change this to hot pink instead of pink, it's going to change all of the buttons because all of the buttons, since we're calling them down here, they all use the same code. So I wouldn't have to change the fill in a bunch of different places. I just change it in the one place that defines what a button is, and then all of my buttons are going to update with that change in code. So that's the other thing that makes functions very powerful. I can separate the different components of my program. I can have one function that deals with what a button is, and then I have a different area of my code that actually decides where the buttons go. So this function, I can make changes to how a button behaves and what it looks like. In the other function, I can focus on the general design. Maybe I think this button should be bigger. I could change this to 40, and I don't have to worry about how the buttons actually work to make those changes. So in this way, we can start to make different modules or different groups or like little sections of our code to make it more organized and to make more robust programs. You can, if you look at any given application, you can see that it's repeating the same things a lot. Like if we just look at the interface for Discord, which we're all sitting on right now, everybody has their own avatar, everybody has their own box. And the box has their name, it has, buttons that you can press on. So all of these things are the same, and it would be inefficient and probably impossible to write a program where you have to write every single version of this. So what we do instead is we define when we have, somebody logged into Discord, this is what it's going to look like, and we're going to reuse all of these different components for each one of our users. So that makes the platform much more powerful. Um, Okay, let's see. I think that is it for this lesson. And so let's look at the schedule again for a second. So I'm going to go back to week 9 here. And I'm going to show one more thing in a second. But so for this week, last week we made this this randomized pattern. And what we're going to do this week is we're going to create an interface for this pattern. So today we talked about using a button, we talked about functions, and then on Wednesday we're going to talk about using HTML interface elements. So instead of having to write a button from scratch, we can just plug into existing buttons that HTML provides for us. So that's what we'll talk about on Wednesday. One thing that I'll show you guys real quick, since we just created a function in P5, I'm going to save this and let's go to our lesson from last week. So I'm going to open up loops press random. So remember last week we made this thing and we had to put it in setup and not have a draw function because we didn't want to keep drawing this over and over again, 60 frames per second. So what we can do now, and what we'll do with this pattern going forward, we'll make some more modifications to it, instead of having this whole thing in setup, what I can actually do is abstract this pattern. So for my setup function, I can end that here, and then I can actually just create a new function called pattern, like that, and then I'll just call the pattern function. So just like I did with my button, oops, I wrote that wrong. So now I can call pattern. If I don't call pattern, it's not going to run. But if I call pattern, we'll get our little pattern here. I don't know what this is for. Let's just delete this for now. And then I can also get a new pattern. Instead of running the whole sketch again, I'm going to turn off this save. I'm going to call the pattern function again. So this is another advantage of creating functions, is that we can make them interactive. So now every time I click on the canvas, it generates a new version of my pattern. So instead of having to run the whole code again, I can just use interaction, and I can encapsulate, I can take sections of my code and put them into functions and then run them at different times, like once when the program starts, and then anytime the user clicks the button. So that's another good use of functions, another example of how we can abstract parts of our code into different sections of our program. So yeah, on Wednesday, we'll look at a couple more things we can do to give the user control over generating our pattern. So they can not just control, when it gets refreshed, but also some of the elements that make the pattern work the way it works. So we'll go over that on Wednesday. And yeah, that'll be our second pattern assignment. So let me stop recording.